Fine. So we start again. This is the final lecture for today, for this part. This is another aspect of sustainability. We talked about tunnel construction. We talked about different aspects in the phases of construction, of the design construction. Another very important point in the for the sustainability point of view is the operation phase. Because during operation phase, there are a lot of actions to do, mainly about maintenance of the structures, maintenance of equipment, and of course, if we want to have a sustainable approach of these phases, it has to be prepared, it has to be conceived in the design phase. So we talk about operation, we talk about maintenance, but this issue is one important issue in the design phase. Usually, people say, we are in the construction, let's think about operation, let's think about maintenance later on, when the tunnel is completely finished. But we'll see that if we want a global view of the impacts, global view of the quality of a design, we think about these issues in the first phase also. It is very important. So my presentation is entitled Maintenance Plans for Tunnels, including structures and equipment. It could be road tunnels, because road tunnels are strongly equipped, but it can be also all kinds of transport tunnels. First point, this is part of the life cycle approach, is the life cycle cost approach. We didn't talk about this specific aspect today, but it's important to have a few ideas of this approach, LCC approach. I talk about life cycle analysis, meaning the footprint, the main environment impact, how to evaluate. In this part, it's a cost, but life cycle cost approach, which gives a global view of all the costs of the project. This aspect, life cycle cost, receives increasing attention. And if you go through the literature, if you go to the research work worldwide, you will find a lot of papers about life cycle approach, life cycle design. There is also a working group in the ITA, which has been created, dedicated to this aspect. The objective is to think from the beginning how to reduce the cost throughout all the life cycle stages. It's how to ensure a very high service level, but also availability and safety, and of course with the lowest cost as possible. How to minimize the impacts of maintenance tasks on the service level. If I need to close the tunnel for maintenance every month, and it's not acceptable anymore, so we have to think how to reduce this closure time. Objective is to improve the sustainability level in accordance with the international agreements to fight against climate change. So all these aspects are linked. When we talk about sustainability, we see construction, operation, maintenance, all the phases have to be considered. The life cycle cost approach is to avoid that the decision is taken only with the immediate cost. If you want to construct the tunnel, you'll compare the cost, the construction cost, and say, that's it, this solution is the best one because the cost is reduced. But what about the future? What about the cost that will be needed in the future to operate the structure? So the initial choice can have consequences over a very long period of time, several decades. Of course, in economic approach, the future, what I have to pay in the next years cannot be considered as having the same value as what I immediately pay. If I pay 100 euros in 10 years, it's not the same value that if I pay 100 euros today. So there are some well-known conventional economic approach that can deal with such a problem. And it's necessary because if we want to compare different solutions, for example, one which is less costly, which is to construct, but more expensive with time, most expensive to operate, how can I have a good balance comparison between these solutions? And so life cycle cost models have been developed to be able to do that. I give an example. This is a model called modular process approach, developed by our German colleagues, Markus Tewes and other authors. We try to work on the question. This is not the only one, but this one is interesting because of the methodology. For example, we consider the phases: construction, operation, recycling, and all the processes within each phase. For example, for construction, we have design, then construction. That's simple. But if we consider operation, we have many tasks, many processes to do. We have to clean the tunnel, we have to make inspection, we have to have repair, replacement, modernization, and this is a cycle, and we have done for several times. All these tasks are called processes, and we can imagine all the processes that will be needed. And the work of the modular process approach is to identify all these modular, all these processes. And on this scheme, for example, you can see the time in red on one axis, and all the processes. And so at the beginning in blue, there is a construction, the design, and the blue light, the construction, and then operation. And during operation, there are many tasks, for example, cleaning, periodic cleaning, you have service operation, inspection. All the processes can be organized in the time. You have a global view of all the processes that will be needed, like a time schedule. The work has been done in this way. And to do that, the tunnels, when I think a tunnel is global object, I have to break down it in the system, in many subsystems, and progressively modules and elements. I mean that to be able to handle such a system, it has to be divided in small elementary elements. And all the interest of such a methodology is the way the things are done, or the way we can divide the tunnel in different elements. And of course, elements will have some processes during time, and it gives the global view of all the tasks. So, for example, for such a method, we can break down the tunnel system in elementary modulus, or elements, many tasks, allocate to each module the appropriate process, and so define all the action that will have to be carried over time, the frequency of each one. Estimate and predict the cost of each one. So I know what are the costs today, so there's the cost. To recalculate the cost, for example, to relate them to the reference time, I mean the cost that I will have to, the payment that I will have to do in 10 years, I recalculate the value that it means today in order to be able to sum up all the elementary costs and give a global cost today. And so if I have different scenarios, different investment, I can compare a very cheap initial investment, but with many, many tasks of maintenance will be expensive. I can compare it with a very high investment today and low maintenance cost. This is a very interesting method to this approach. Just a thing, this is just to remind you what I called the way to calculate, to relate the cost to the reference time point. It's just a formula, very well known in economic approach. And for example, the cost, what I call cost one, that I will pay in 3 years, if I have to pay 500 euros or dollars in 3 years, it means something like 432 euros today, according to a formula with the interest rate. This is a very well-known formula in economy. So, for example, everything can be calculated at the reference time point. This is what has been implemented in the method. So this is what we call the life cycle cost method. To go further in all the action that will be necessary to carry out during the life cycle, there are different ways. First, we know that there are actions that are defined in norms or standards. Mostly, if you use electronic components, safety equipment, there are regular controls. They are imposed by regulation, so you can know exactly what you have to do. You have also some national regulation or local recommendation. And in many countries, for example, you have recommendation for good practice for operation and maintenance. And it gives the frequency of the action you have to do, the kind of action you have to do. And so you can input such action in the methodology. And for the others, they are the result of a particular tunnel maintenance policy. Especially tunnel owners can choose to have a very high level and impose some actions. Also, public-private partnership. There are contracts between them, and all these tasks are imposed at the beginning. And if the private sector has to sign the contract, he wants to know exactly what task he will have to do during every year in the future. And so he needs to be very clearly informed of all these aspects at the early beginning. Okay, so this method, life cycle cost, is increasing. There are many research about that, and this is what we call the global cost, and many works are done to be able to calculate it at the early beginning. Now, I come to a very important point, more practical one, which is the maintenance plan. if I have the best construction, the best tunnel, I'm very happy with the construction, very happy with what has been done. It's time to operate. And we need to have precise maintenance plan. We know, for example, in our tunnels that we invested a lot of money for safety requirements. When in his presentation, Robert told that he wanted to avoid tunnels with bidirectional traffic in it for safety requirements. It means that for safety requirements, we put large amounts of money in ventilation, safety, facilities, facilities for evacuate people, a lot of things. But if we don't care, we know that after, let's say, 2 or 3 years, for many, many reasons, we can have trouble. I mean, evacuation is not working anymore, ventilation is out of use, many, many things can be deteriorated very, very quickly. And so, maintenance plan are a key element in the sustainable policy. We have seen that the life cycle cost approach can optimize the global investment, but provided that the maintenance policy is clearly defined and carefully implemented. Even if the strengths of the material go, as said Robert, increase with time, the strengths, but we know that all the components are subject to aging in a very aggressive underground environment. We find equipment, for example, ventilation, fans, something like that. After 2 years in a tunnel, they cannot be used anymore. A very aggressive environment, difficult to qualify, but it's the case. So all the components are subject to aging. There are many, many more electromechanical equipment than in the past. For safety requirements, they are very equipped. Safety requires very reactive and high-performance installation and equipment. And also, men and organization need to be challenged periodically to not settle down into routine. So it's important to work, to maintain, to keep a permanent attention to what is done and to all this equipment. And these things is not so easy to do, and it requires maintenance plan, very clear maintenance plan and well-defined. It's especially the case in urban areas because the risk is very important in urban tunnels. The level of traffic is very high, generally. Every event in a tunnel, it could be a breakdown, a fire, everything you want, will involve a lot of people, a lot of cars, a lot of people in a train, a lot of people in a bus. So it means that the consequences are very high. If you close the tunnel for maintenance, people are not happy. So the pressure is high for very short intervention, very short closure. And also tunnels are submitted. I don't know if it's the case in Argentina, but it's the case in Paris, for example, where a lot of degradation in the tunnel, terrorist threats, illegal crossing of escape facilities. In urban areas, people go in the escape facilities from the surface. It's very difficult to be sure of what happens in a tunnel and to control it. So there are many, many, many reasons to care about the tunnels. Even if we have very good plans, maintenance plans, reality saw a lot of situations. For example, this tunnel, there is an escape facility here. if there is a fire in the tunnel, normally people can evacuate through the door. This is an evacuation facility, but impossible to open the door clearly. So how to do that? This one is trouble with the pavement, with squeezing soil. So this happens, and this is a drainage duct, and cannot use it anymore because of the deposit with time, no cleaning, and so there is no efficiency in the drainage. So the tunnel cost millions of dollars, millions of euros, but it can be totally compromised by water because of a single drainage system that doesn't work anymore. And so we have to care about all these questions. So in a sustainable approach, tunnels, the whole tunnel system has to remain very efficient, effective, and reliable over time. All the components have to be ready to operate, in spite of big differences between infrastructural components and electromechanical ones. For example, if I consider the structure is, need care, maintenance, sometimes some refurbishment, but infrastructure components have a long lifespan. They don't need to be repaired every year. It's a long period of time. But equipment is completely different. They need periodic control, replacement, and their lifespan is very short. And so you have to deal with two different time schedules, one for structures, one for equipment. And the boss needs something, the very different approaches. It must be combined, but this is different approaches. So this is possible only if a maintenance policy is clearly defined and formalized in a document for both civil engineering structures and equipment. And this document must describe all the processes, organizations, and responsibility. Who is in charge of what? If it is not clear, probably the task will not be done. It has to be assigned clearly and with a system of reporting. Every action must be reported in the plan. I give you on this slide some references. If you want to go further on this topic, you can have documents from ITA, International Tunneling Association, and there is a website who published a document of maintenance and repair. Also PARC, which is the International Road Association, donc mainly road tunnels, exclusively road tunnels, and there are different documents in 2012, in 2005, and recently, 2016, documents of BEC, for example, best practice for life cycle analysis for tunnel equipment. And this is a very interesting document. We have a lot of information. We have also different documents. So I see SCA, Swiss norm on maintenance infrastructure, German guidelines for equipment and operation, or we'll say a document in the French legislation, a French regulation for tunnels. And all these documents are available and gives references to how to build, how to put in place a maintenance plan. A few words about these plans. First part is we have common action for both structures and equipment. Common action is a written maintenance policy, written, very precisely defined, and generally with 3 levels of responsibility. Who decides, who organizes, and who works on the field. It cannot be the same. It has to be organized from the decision, organization, and the work properly done. So it has to be focused on the document. You have the necessity of a continuous attention with annual reports of what has been done during the year, what I've seen on the tunnel, what happens, and there is a written report every year on this. And also, and it was the main new elements, detailed inspection and controls with an assessment of the state of each component of the tunnel. And so, if we have this kind of inspection, I will come back later on this inspection, I can be sure on what happened in my tunnel. Let's go a little bit further for the structures. I will talk about equipment in the next part, but this one, let's consider structure. Structure, as I said, the surrounding environment can be very aggressive for the structures. Water penetration, leakage, pollution, squeezing ground. There are many, many reasons that can explain defaults, that can explain what we see in the tunnels. The other aspect is all the maintenance intervention have to be very short. I explain why, and limited in frequency, not to affect, not to have a strong impact on the traffic, for example. And also, no threat to public safety can be accepted. Of course, if there is a part of concrete in the slab that is unstable, I cannot admit that this part can drop on the car, on the vehicle. So I have to care absolutely about the safety. If something happens, it will be unacceptable. Everybody will say this is completely unacceptable in a tunnel. What can be acceptable in other places on road is not acceptable on tunnel. In tunnel, people using the tunnel thinks that there is a responsible. The operator is responsible of everything that happened. It's different on a road. For me, it's different because on a road, if I have an accident, it's generally admitted that the driver is also responsible of the accident. The same accident in a tunnel, we say, what does the operator? I cannot explain. He is responsible for many, many reasons. I don't know, but there is something exactly like in a train or in a plane. If you have a problem in a plane, you will not be responsible. Somebody else has to be responsible. In tunnel, it's near the same. No threat to public safety can be accepted, and the surface level has to remain very high. To categorize the main influencing factors on the structural behavior and the development of disorders, we can have different reasons for that. The site characteristics, the construction process, the aging of material and structures, or also accidental events. I will not go too far on this question, but of course, there are examples of site characteristics. If there is a decompression of the massif, there is a block fall, for example, clearly it's the geology, surrounding geology, which is the reason of the default. The same in this case, when there is a karst cavity under the pavement and explain the disorder in the pavement. So geology is responsible. In this case, this is a defect during construction, a lack of concrete at the crown. So if behind the vault there is a void, Normally, we have to find concrete, but this is only the void, so it's a lack of concrete. This is a default on the construction. Default, lack of coverage of the mesh behind the spec concrete. So this is kind of default. Deposit, drainage network, construction deposit inside the drainage network. It's very, very common that the drainage network is not cleaned at the end of the work. So because of the work, a lot of different things have dropped in the drainage system, and nobody cared about removing them afterwards. So from the very first day, the drainage system is already compromised. It is a very, very sensitive point, very, very sensitive point. Long time effects, long time, like drainage ducts, they are filled with calcite, for example, in this case. This is a long time effect. We have to clean it, of course. Thermal cycles that lead to a failure of the adhesion of the tiles. So there are some, this explain with time the defaults of excessive mechanical scaling due to excessive strength. So many excessive stress. So there are a lot of effects on the structure. Accidental events, I have only this example, which is spalling a fire in the tunnel, and the fire causes spalling, and so reduce the thickness of the concrete. The concrete is completely destroyed, even at very moderate temperature. So after a fire, we have to remove this concrete, to replace it, to recreate the structure around the tunnels. So there are many different reasons to explain the defaults in the structures. So periodic inspection are necessary for safety requirements, for economic reasons, and for compliance with existing regulation. This is a small scheme coming from an European project called Tun Construct. It's finished now, this project, and they try to compare the performance of a tunnel with time. And there is the blue line. The blue line expresses the following idea. The performance level decreases with time. And once we reach the minimum accepted, this is the black line, we have to bring maintenance, corrective maintenance, to give a new performance. And there is this step to give an acceptable performance. And when the performance has been given, it started again to decrease until the next corrective maintenance. What is promoted in the project is not to wait until this minimal performance level, and at a certain time to bring what we call preventive maintenance, to do some actions very early, which is the red one, which means a small action, but this small action can bring a better performance, and then it starts to decrease. We do performance maintenance again. So we keep, over time, a higher maintenance level. And the global cost, if we calculate the cost of all these actions of preventive maintenance, is less than the cost of the corrective maintenance. It means that it is both economically interesting, the cost is less, even if there are many actions, and the performance level is kept at a higher level with time. And this explains what they promote, this kind of preventive maintenance. I do not wait until the breakdown to repair. I do some task, organize this task, even if it has not broken down at a certain time, just to be sure that I keep a very high maintenance level. I will come back on this idea when I talk about equipment. If we look through the existing regulation, this periodic inspection of the structures are compulsory in many places. They are compulsory in Switzerland every 5 years for rail and road tunnels. In Germany, every 6 years for young tunnels, and every 3 years for older tunnels. They are compulsory in France every 6 years or every 5 years for rail and metro tunnels. They are recommended for rail tunnel in United States. I mean, generally, this is 5 or 6 years that the inspection are compulsory in many, many places. Usually, when I talk about inspection of civil engineering, this is very simple ones. This is a specialist coming just near the tunnels with kind of equipment, this basket on a truck, just to be able to look at the structure and to illustrate what is seen. It could be on a paper, a simple paper. It could be made on a digital mapping of the tunnel. I'll give an example. But it's to keep an idea of the state of the tunnel at time. So next time, I will be able to compare if there is an evolution or not. Of course, there are many, many new tools to improve. It could be in visible light imagery, profilometry measurement, which can give a global view of a tunnel. These methods, automatic, are very fast and can go through the tunnel and give a global view. Of course, this is not so precise that the man which comes and inspects very carefully, but both can be complementary in the approach. This is also an example of infrared camera to detect temperature in the structure and give also information. So you give different tools to have a precise idea of the state of your structure, and the specialist can conclude about the state and what has to be done. And for example, this is the superposition of manual one and recorded disorder survey. So they are very complementary just to get a global view. These techniques are in great evolution because of new tools appears, new techniques, new electronic sensors that can help to improve the methodology. This is just a slide to remind that when I think about maintenance of structures, it's important to think about all aspects of the structure, not only the main tunnels, but every part of the tunnel has to be inspected also. Okay, I'll come back to the equipment later on. Equipment is rather new aspect, mainly because equipment comes from safety requirements, and safety requirements have been imposed by the regulation later on. It's mainly after the big fires. I talked about Mont Blanc tunnels. There are also fires in other tunnels, and Robert talked about that. That explain that we impose a lot of new requirements for safety. And it means a lot of systems, electronic system in tunnels. And this electronic system, from what I called to collect the data, to observe what happened in a tunnel, to identify the event, there are automatic tools to do that, to supervise, and then to act. This could be done quite automatically now, but there is somebody, of course, to operate and to validate what happens. But the main aspect have already been identified by the system. The objective is to react very, very quickly. Clearly, if there is a fire, I want the ventilation system to react very, very early. And so it means that the global chain works, and the global chain works only if each of the links works. So it's important to think about all the components. And all the components, they have very short life cycles, and so we have to care about all these different aspects. This is a small list of what has to be controlled in the tunnel itself: the general equipment, electrical distribution, lighting, ventilation, removal of liquids, pumping, liquid treatment, more sophisticated equipment, closed circuit television, automatic incident detection, signalization, emergency phone, radio transmission, water network for fighting. There is a list of equipment that have to work properly. But also, in the technical room, I am not in tunnel anymore, in the technical room, or in the control center. And so, all these aspects have to be controlled periodically. If you want to go further, this is a document of PARC. I talked already about the best practice for life cycle analysis for tunnel equipment. And this is interesting because there is a breakdown of all kinds of subsystems. For example, energy supply, ventilation, illumination, signing, monitoring system, SCADA, or supervision system, cabling, and what are the relevant elements of the subsystem, and of course, he will explain the action to do for each aspect of the subsystem. Usually, in all the different regulations, 3 types of activities can be distinguished. What I call maintenance. Globally, there is maintenance itself. I will precise what I need. It means. We have controls and then refurbishment. And all these 3 types of activities pay attention. Maintenance, I already explained that there are 2 sorts of maintenance. The corrective one, which is the most, we can find it everywhere, corrective maintenance. We wait where is a partial or complete failure of the system, and then we repair it. So we wait for the breakdown to repair the system. But preventive maintenance, I explain it is economically interesting, financially interesting, and also provide a higher performance. Preventive maintenance is carried out according to a fixed criteria, and we prevent equipment from breaking down. We have periodic-based maintenance. We have a schedule, and every month, for example, we have an action to do on lighting. Even there is no breakdown, we have different action to do. And also we have what we call condition-based maintenance, mean that we define thresholds. And when the thresholds are reached, we can plan the intervention. So clearly, all the documents, all the methodology say a priority to preventive maintenance. This is the choice for economic, and it's not so easy because preventive maintenance, I will, for example, change the lights in the room because they are old, because for many things, even if it works. So it's not so easy to explain that it is economically interesting to change them today. It needs an effort to think about that. And in this slide, for example, we can see that there are different tasks to do, different level, 1 to 5, from the simplest one, number 1, which is washing, cleaning, painting, which is very simple task to do, to the more complicated one, number 5. And the 3 first, they are directly relevant to preventive maintenance. They can do, I can control, I can check everything as in preventive program. Number 4 is corrective maintenance, because repairing breakdown in very standard equipment or complex equipment. And number 5 is more complicated. So I already explained corrective or preventive maintenance. Clearly, corrective maintenance is not recommended because you cannot plan what you want to do. You wait until it breaks down. We don't know when it will happen. Perhaps it will happen in the vacation time. There is nobody to repair it, so it's okay, it's a problem. So there is no corrective. You can have a problem, but no spare parts, nothing available, and so it will require time to remove the equipment, because you have to find the spare part, you have to install it, to find the people. So it cannot be considered as, it can be considered as pertinent only for very basic tunnels that are not highly equipped. But if you go for more complicated tunnels, more sensitive ones, preventive maintenance is the best thing. You can plan intervention, you can be sure that you have the spare parts available, and you can also choose to operate with the limited impact to traffic. Okay, and I come to the control. When you have inspection, you can have different control. We can distinguish what we call the regulatory controls. You have many things that need to be controlled. For example, electrical devices, extinguisher. I don't know if the same in Argentina, but probably. But if you have extinguisher in this room, you know that every year it has to be controlled by somebody which is an expert in this question. Or there are a lot of equipment that needs regulatory control. You need also to have a specific safety control. If, for example, you have a ventilation system or smoke extraction system in a tunnel, it works when there is a fire. It means that very rarely, perhaps last year, there is no need to act the smoke extraction system. No accident, no reason to do that. So you have to try to use it. You have to check if it works, because if you don't use it periodically, you are absolutely not sure that it will be operational when you need it. So this is the same for a different system. Emergency closure system, evacuation system, all of them need periodic text. Usually every year is recommended in a text. Every year use as in a test all your system. And the detailed inspection are complete verification of the quality and the performance of the system. Generally, every 6 years, 5 or 6 years, according to the national regulation, you have to check the quality of your equipment, you have to use it, you have to see if you have the spare parts. Everything has to be checked. It's what I detail on this in this slide. When the tunnel is opened, for example, it has just been finished to be constructed. So just after that, we have the initial inspection to control the quality of the equipment, what has been installed, to be sure that everything is okay. You can measure the performance of your equipment. What is the exhaust power of my ventilation system? I can measure it. You can have functional tests per equipment, per scenario, per equipment for each lighting system, or for more global, from the closure system, means a lot of equipment. So we can conduct tests and also specific safety controls. And in the periodic inspection, 6 years after, I will come back on the same topic and I will measure the performance. I will be able to compare with the initial ones. I can also conduct the tests with all my equipment. I can check if my spare parts are available or not. I can say if the system is obsolescent or not. So this is part of a sustainable approach of my equipment. And after an inspection, what is interesting, if you can score each family of equipment. For example, in this case, I consider the 5 families of equipment: power supply, high voltage, low voltage power supply, lighting, ventilation, SCADA system, and I score first the performance. I mean, 1 is very good, very performance system, or 4, poor performance system. The performance is poor. And I can also qualify the state, because I can have an equipment in very bad state, but the performance is good. Or I can have the contrary. I can have a very poor performance even if a good state, in an equipment in good state. So, for example, P2, C2 means a good performance and good state. And so this kind of scoring is introduced in different regulations and also recommended by PARC, gives a global view of your system. And in the document of PARC, it explained the different criteria, how to score the different families. I can go. For example, this is coming from PARC. For example, on the left, there is a curve. This is the score of the energy supply system. And there are different criteria, and there is a score. For example, from 1, 2, 3, 4, which is done. In this case, 4 means 4 and 5 are the poor system. The best score is the number 1. And so, according to the different criteria for the energy supply family, we can have a score. This is the first curve. Give a shape, immediate shape. You know exactly where your tunnel, how is your tunnel according to the energy supply system. And the second scheme, it takes the average score for energy supply system and the average for ventilation, average for monitoring, SCADA system, and the global curve in red in the second gives a photograph of your tunnel, all the system, and so you can see where you are scoring, what is the family which is in bad state, bad performance, and you can compare with the previous inspection of the way the evaluation of your tunnel, the way the evolution. Okay. A word about refurbishment. I will be very, very quickly done, because the refurbishment of equipment I mean, it's a very important operation. It happens when we consider there is a real danger for the users, and so or you have excessive loss of performance, non-availability of spare parts. It means that you have to renew, literally to renew your tunnels. And so this is a refurbishment. We refurbished a lot of tunnels in the past 5 years, especially because all the old equipment could be considered obsolescent, and it was a very huge operation. So, on the slide, this is a brief summary of the 3 aspects: maintenance, control, refurbishment, and the task, the main task we can find in different categories, and also when it has to be done, the deadlines. So it gives a global view of what has to be done considering equipment aspect. Okay, so it's not so easy to deal with this question because it's the training is more civil engineering oriented, but equipment is also a part in the sustainable approach. I would say in conclusion that the end of the construction is very often considered as the final step. We have done the construction, that is okay. But I am strongly involved in all operation aspects and all safety questions, safety issues. And I know that there are many problems during operation. And in fact, it's the end of the construction is the beginning of something else, a new process with very complicated issues related to safety, to efficiency, to cost, to responsiveness. So it means that we have to care about that at the strict beginning also. The tunnel operation is a global system in which the global reliability is dependent of the reliability of each component. If something doesn't work, especially in equipment, the whole system doesn't work. So we have to care about everything and to do that periodically. This is only possible if a precise maintenance policy is established and respected. It is not so easy to do that. It has to be defined, and actors, all the stakeholders have to be involved in that. Maintenance plan is also an important component of the sustainability approach of tunnel design and operation. And also, the development of maintenance plans, if you are able to plan the different action you will do, you can come back to the beginning of my presentation when I talk about life cycle cost, because you know exactly what you will have to do, especially if you are in a preventive maintenance. You can plan from the beginning all the action, so you can calculate their cost and to bring it to the global cost of the structure in a life cycle cost approach. And so you can have a comprehensive and a global comparison of all the different solutions. That's it. Thank you very much.